Welcome everyone to section 5.1. This is factor by grouping. We're doing an algebra related concept today, and this mural is in honor of President's Day, which is coming up next Monday. All right, let's go ahead and get started. What does GCF stand for? You've probably heard this 7th grade, 6th grade, 8th grade, but it's always good to get a refresher. It stands for the greatest common factor. What factor is the biggest, greatest, that's what greatest stands for, the biggest between two terms? What do they have in common? The greatest common, meaning shared, factor. So if we're looking at example A here, we have 8x and 12. Now clearly what we need to do here is analyze first, do they have a shared variable? They don't. So we're just going to simply look at the coefficients. What do they have in common between 12 and 8? Well, now we're just thinking of what's the GCF between 8 and 12. The GCF between 8 and 12 is 4. That is the greatest, the biggest number that is a factor of both 8 and of 12. That's what that means. So the GCF is simply 4. Moving on to the next one. Now we see that we have not only coefficients in front, but we also have variables in the front or next to it as well. So we're going to have to essentially find the greatest common factor between our coefficients and our variables. What's the greatest common factor between our coefficients? Well, we have -7 and 14. What is the greatest common? What do they have shared between them? That's the biggest factor of both. 7. So we can factor out a 7 from both of those numbers. Okay, 7 goes into -7 and 7 also goes into 14. What is the greatest? And that's that one. What is the greatest common factor between x squared and x? What can you multiply that goes into x and also x squared? That is x. X times 1 gives you x. X times x gives you x squared. X is a factor of both. It's the biggest factor that goes both into x squared and x. So there you go. There is your greatest common factor for letter B. And letter C, okay, we have no numerical coefficients this time, but we have x, y, and z all as variables. So now we just need to think to ourselves, okay, what's the greatest common factor of x? We have an x squared and an x. That means the biggest value that we can have is x. X times 1 gives us x, and then x times x gives me x squared. What about y? The greatest common factor between y and y squared is going to be y. And then for z, we have z and then z cubed. Although z and z squared and z cubed are all factors of z cubed, we only have a z over here, so the greatest common factor is simply z. So we have x, y, z as our greatest common factor. Now, how do we apply this to factoring? Factoring is the process of essentially going reverse from distributing. For example, if you had something like 2 times x plus 1 as a very simple example, to distribute would get 2x plus 2. Now to go in reverse from 2x plus 2, we need to think, okay, what's the greatest common factor between 2x and 2, those two terms? Well, let's just go ahead and apply it to our example. We've already done the work here. Okay, that was just a simple example. We've already done the work with x plus 12. What we're trying to do is go in reverse. What do we multiply out in front to get 8x plus 12? What can be multiplied, distributed to get those values? So we always think of the greatest common factor to get the factor, to factor it in its most simplest form. So the greatest common factor we already determined was 4. Okay, what does this mean? Well, what we're going to do is we're going to take out a 4 from 8x, and we're going to take out a 4 from 12, and that's how we go in reverse. The process is this. We do 8x divided by our greatest common factor plus 12 divided by our greatest common factor. Okay, so factoring is really about dividing by the GCF. And then you put the GCF in front. So essentially you put your GCF in front, and then you put your term number 1 divided by the GCF plus your term number 2 divided by your GCF. That's kind of a, I guess, a formulaic way to think about it. I'm not a big fan of just formulas and whatever, but That's the process, okay? So now we just do 8x divided by 4, and we are going to get 2x, and then we do 12 divided by 4, and we're going to get 3. So our factors now of 8x and 12, to break it down into factor form, okay, two factors are two numbers times themselves to get the desired outcome. We have 4 times 2x plus 3, and if we distribute that, we're going to get this right here, okay? All right. Moving on to the next example, we already broke down the greatest common factor. This time we just rearranged it a little bit to have the negative 7x squared as a subtraction instead of as a negative out in front. So what we're going to do is we're going to put the 7x out in front, and then what we're going to do is 14x divided by 7x, and then we're going to have negative 7x squared divided by 7x. I'm going to go ahead and write this below this time, just so you can see 7x, and then we get 14x divided by 7x, and this is 2, minus, the 7s are going to cancel, and then we have one of the x's in the bottom, cancel one of the x in the top, and we get minus x. So we have 7x times the quantity, 2 minus x, and that is our factored form. Final example, we already determined is going to be x, y, z. And so we essentially just need to divide each of these by x, y, z. We're factoring out an x, a y, and a z. Now, you can do this in your head if you want. If you don't like that, again, just go x squared y, z divided by x, y, z, and then cancel from there. So essentially, you're going to cancel the z's, you cancel the y's, one of the x's cancels, and you're going to be left with just x. Usually, you're going to copy this sign like that. Unless you factor out a negative, then it changes a little bit. So you're going to copy that sign, and this time I'm just going to kind of visually do this. So I know I'm going to be canceling this x with that x, so there's no x left. Cancel one of the y's here with that y, cancel that z with one of these z's, leaving me 2 z's left. So I get y z squared left over, and that's going to be my final answer for factored form. So again, we're starting with the GCF, then we're dividing each term by the GCF. Example 2, factor out the GCF. Okay, we need to first consider our coefficients, our numerical coefficients. What is the greatest common factor? I'm thinking 8. There might be something bigger than 8. I don't think so, because I know 8 is a factor of 32, 24, and 40. So I know I'm going to factor out an 8. Now I need to look at my variable. So I see p, and I see that my smallest p, that's where you start, my smallest p is to the 3rd power. So you always go for the smallest one, and everything else is going to be terms of the smallest one. Now that I have that done, I can go ahead and get my parentheses set up, because I'm going to take each one of these terms and divide by the GCF, which I already put in front. So I do 32 divided by 8. That's going to give me 4. And then I do p to the 4th divided by p to the 3rd. I can use the quotient rule and subtract exponents, or just think of it as canceling p to the 4th over p to the 3rd. And I'm going to get just p. Then I'm going to copy down my minus sign. If I don't factor out a negative, I'm just going to copy this down. Minus 24 divided by 8 gives me 3. And then p cubed divided by p cubed is just going to give me 1. So I'm just going to leave the 3 and move on to the next term. Plus, because this is plus and I didn't factor out a negative. And then 40 divided by 8 is 5. And then p to the 5th divided by p to the 3rd is going to give me p squared. Now, if you want, or if your teacher requires, you should probably write this in standard form. So 8p cubed times the quantity 5p squared plus 4p minus 3, and that will be my final answer in factored form. Now, sometimes we can have polynomials written as our different terms, and now we just have to look, and this is already a little bit in factored form, but there's still more we can factor out. What we need to do here is, this looks a little bit more complicated, but we're still looking for terms. Just how we had 2 times x plus 4 times x, we see that we had a 2 in common with the coefficients and an x in common with both. Or I guess it would be better if this was x squared or something like that. We have an x in common and a 2 in common between both. We're still looking for, sorry, having some pencil problems here. Eraser, there we go. We still need to look for common factors, two things times each other. So these two parentheses are multiplied by each other. So we need to think of each one of these parentheses as a unit. We have this green one times this blue one. Think of this as one term. Okay, one piece of information. No, I don't like that. There we go, that's better. Okay, and then this one times this one. Okay, two things times each other, but we can factor out one of those things. Okay, so again, what do they have in common? Well, we see that we have an x minus 5 and an x minus 5, so we can factor that out. That's a factor for both this first term and for this second term. Terms are separated by addition or subtraction. So we see x minus 5 is common to both. Okay, what's left? Well, what's left is x plus 6 plus 2x plus 5. That's what's left over. So just as a recap, we factor out this x minus 5 because this could be distributed among both, and then we would get this big thing because x minus 5 times x plus 6, and then plus x minus 5 times 2x plus 5. So that's how we can factor that. Now we just need to simplify parentheses. So we're going to leave the x minus 5 out in front, x minus 5. And then in parentheses, we're going to combine like terms, okay? Because when there's nothing left to combine, essentially we can just drop the parentheses. And we're going to have 3x plus 11. So that is another way to factor this. Well, not the another way to factor, but that's another example on how to factor things that seem more complicated than they actually are. Okay, we see that we have a term here, x minus 5, in both terms, so we can factor out that whole parenthesis. If you want, you can leave it like this, but if you were to do that multiplication, you would get the same thing. Example 4. There's two different ways to factor out these polynomials. Okay, so as you can probably guess, the first way we would do is we'd look at numerical coefficients. We see that we have a -1, a 3, and -5. They do not have any common terms, so we're going to have to look to or common factors, so we're going to have to look to our variable next. We have a cubed, a squared, and a, so our biggest one is just a. So we're going to factor out the a, and what are we left with? We're left with -a squared plus 3a minus 5. Now, that is one way to do it. Another way to do it is factor out a -a. This is useful to think about because sometimes we want to make sure that we have certain terms positive, especially our biggest degree. So this -a squared, if we wanted to make that positive, we could factor out a -a. How would that affect things? Well, we would get a positive a squared minus 3a plus 5. So think about doing the opposite in the parentheses that we had before. We had a -a squared and a -5 before. And now we have a positive a squared and a positive 5 because we factored out a -a. When you divide -a cubed by -a, it becomes positive a squared. That's where the positive a squared comes from, right here. Okay, so if you want to have that a squared positive, you can factor out a negative. And that's useful because sometimes it's going to be a lot easier for us to have positive terms. Anytime you have polynomials with more than 3 terms, you can use grouping. Okay, factor by grouping. How do you group? Well, you're going to group the terms so that they have common variables. Okay, so here I already helped you out. We have the x's that are in blue, and we have the y's that are in green. So we're going to put the x's next to each other, and we're going to put the y's next to each other. Okay, this will help us visually for the next part. Okay, so we're going to factor within the group. Boy, I should have used a different color. Oh well. We're going to factor within group using the GCF for each group. Now I need to fix that C so it doesn't look so hideous. Okay, so we're going to factor within the group. So we have this group here and this group here, so we need to factor within each group. Well, how do we factor within this group? What do we have in common here? We have this x and this x in common, but the coefficients are not in common, so that's fine. And then for this one, we have this y and this y in common, so we're going to factor that out. So let's go ahead and show what that looks like. We're going to take out the x. What's left inside? We have the 2. Okay, what's left over is the things that don't have an x in them. The 2 plus a, and we're going to leave that in parentheses. Plus, now we're going to go to purple because we're factoring out the y's. So we're going to factor out the y's, the thing they have in common. The y's are in common. The 2 and the a are not common factors, so we're going to leave those alone. 2 plus a. So that's our first step. We're going to factor within the group using the greatest common factor. Factor the entire polynomial, okay, this entire polynomial, further if possible. So if we can factor further, we're going to do that. Now, how do we know if we can factor further or not? Well, again, we have terms separated by addition or subtraction. So here's my addition sign. So I know I have this as a term. Yuck. Let me try that again. I know I have this as a term, and I know I have, let me use a different color actually, maybe this pink. And I know I have this as a term. Okay. Are there any factors common between those two terms? And the answer is yes. I have this 2 plus a and this 2 plus a. The x and the y are not common factors. They're not in the same variable. But 2 plus a is the same. It's identical. So guess what? I can take out the 2 plus a. I'm going to factor that out. And now I say, okay, in the two terms, what did I not take out as a common factor? What did I not underline? And it's this and this, the x plus y. So I'm going to put parentheses. And the factors that I did not take out, I'm going to add them together. So I have x plus y. And now I have this completely factored. This is my answer. A way to check it is we could distribute and we'd get the same thing. So we could go our distributive property here, just to show you real fast. Sorry, I know this video is already a little long. 2x plus 2y, and then plus ax plus ay. See how we get the same thing that we started with. Okay, just a little bit rearranged. So that's the process that you can do. This is grouping that will help you with any polynomial of 3 or more terms. Let's go ahead and apply it this one. Again, we want to first pair up our like variables. We have 6ax plus 12bx plus a plus 2b. Now, the temptation might be to use x, but you can see that we only have 2 x's here, whereas we have between a and b, we have 4 of them. Okay, so we're going to actually factor by a and b. So we have an a here, and then we have a b here and a b there. So we're going to write the b's and the a's next to each other. So we have 6ax plus a, and then I'm going to put the b's next to each other, plus 12bx plus 2b. Now, between each group, I'm going to see if there's common factors. Okay, and again, I didn't use the x because there was only 2x, okay, where these are by themselves either had an a or b, so I'm like, oh, I'm gonna settle for a or b here. And there's also more than one way to do grouping, just so you know. This isn't the only way to do grouping, but this is the way I'm showing, just for clarity. Okay, so then we have, what do we have common factors here? We have a and a here, so I'm going to factor out an a from this group, leaving me 6x plus 1. Okay. Over here, what do I have? I have a b and a b. Oops, I want to go one line here. I have a b and a b, but I also have 12 and 2, which now we have a coefficient, which is kind of cool, because now we can factor out a 2. A 2 is common among both 2 and 12, and then a b is common to both. But what is left? I'm going to have plus here, because this is a plus sign. What's left? Well, I do 12bx divided by 2b, and I get 6x. Then 2b divided by 2b, my greatest common factor, and I get 1. That's my first step. Again, now we're going to be looking for, okay, do we have any common factors between these two? And it is, yes, we do. We have the 6x plus 1. So I'm going to factor out the 6x plus 1. 6x plus 1. Okay, I'm going to leave that in parentheses. And then what's left that I did not factor, I have A and then 2B, and there's a plus sign in between, so I'm going to keep this positive. And now this is completely factored. That was factored by grouping. That was factoring the greatest common factor. That was factoring polynomials. Hope you enjoyed this video. Join us next time as we do more factoring principles. Thanks for watching.